In this slide, I'm going to show you what is a programmable logic controller, or in short, we call it the PLC. So the PLC is the brain of the system, or we call it the signal processing element in the control chain. You can see from this photo over here, we are showing you the Omron NJ101 series PLC, which we will be using in our lab. So this PLC has several units or several modules, as you can see over here. Let me explain to you one by one what are all these modules about. So first, we have this power supply unit, where it will supply power to the CPU, which is the computer processing unit. This is where all the programs are being stored inside this PLC. Using the software, we will install on our laptop or our PC to type out the program and then transfer the program via Ethernet cable. So there are several communication protocol that we can use. We are using Ethernet LAN cable, okay, to transfer the program from the PC to the PLC. We also have the input card, where we wire all the input elements to this input card. Input elements such as buttons, sensors, switches. And lastly, we also have this output card, where we wire all the final control element or the output elements to this output card, such as light bulbs, buzzers, solenoids, or even motor contactors. So this is the overview of this PLC. Let me give you a very simple example on how we can use this PLC. So for instance, I have a very simple application whereby whenever a sensor senses, the light bulb will turn on. So I will wire a sensor to this input card and a light bulb to this output card. And I will write a simple logic, okay, and transfer in the program to this CPU such that whenever the sensor senses, the program will execute and then it will set the light bulb to turn on accordingly on this output card. So this is just a very simple example on how you can use PLC to be implemented in a control system. In this following slide, I'm showing you the Omron NJ101 PLC block diagram, okay? And as explained to you earlier on the left here is the power supply unit. In the center is the CPU, the computer processing unit. And we have this input card where we actually wire all the switches and sensors. And we also have this output card where we wire the final control element or even the output elements such as light bulbs or buzzers, okay, in addition to contactors or solenoids. So this Omron NJ101 PLC has three types of communication protocol. We will be using the Ethernet protocol, okay, in our labs. So with this, I hope you have a better understanding of how does a PLC looks like and what does a PLC do, what modules does the PLC have, and we shall now go to the worksheet to take a closer look on the internal operations of the PLC. We are now at worksheet 5, PLC chapter 1. PLC stands for Programmable Logic Controllers, and today we are going to study the internal operations of the PLC. As I have taught you earlier, PLC is the signal processing element. It is the brain of the system. So as you have seen in the earlier video, you know how a PLC looks like. So over here, we are showing you the generic block diagram of the PLC. On the left here, we have the input module, and on the right here, we have the output module of the PLC. In the center here, this is the brain of the system, which sometimes we call central processing unit, where you will write the program using your computer and then transfer the program into the PLC. So what do you connect to the input module of the PLC? We connect all the input devices such as buttons, limit switch, sensors, okay, and so on and so forth, all the input elements. And what do we connect to the output modules? Okay, we will connect the output elements or final control elements. So you can see the solenoid is being connected at the output module, and we also have the motor contactor. Sometimes we even connect the light bulbs, okay, which is also an output device, to the output module of the PLC. Hence, if someone press the button, okay, according to your program logic, the output devices will react accordingly, according to a program logic. So for instance, if you press the button, okay, according to a program, you may be switching on the solenoid, okay. So depending on what logic you have written in the program, the output devices will react accordingly. So this is how a PLC is being used. Now we will take a look at the section over here, input-output processing. So the input-output processing over here we're referring to is the input module and the output module, and how do they process. So to allow for rapid program execution, all the inputs, okay, are read into the CPU at the start and at each program cycle. The status of the inputs are stored in a memory buffer called the RAM, okay. For those who are familiar with computer, you should know what does a RAM stands for. RAM means random access memory, okay. So for the benefit of those who do not know, so random access memory is just another memory area of the PLC. As the program is executed, the stored input data are read into one at a time from the I/O RAM, and outputs that are to be set or reset are stored in the I/O RAM, okay. So what does I/O stands for? I/O stands for input/output, okay. So at the end of the program cycle, all the output status, okay, are then being transferred to the output points that drive the output devices. Okay, the output devices can be lamps, can be solenoid or motor contactor, depending on what you have connected to the output module of the PLC. So this whole entire process, right, okay, is called the I/O refresh. Okay, and as I have already told you, I/O stands for input/output, okay. So now we will go on to the next page. So you can see this is typically what the PLC CPU is doing. First, you will read the input. After that, it will execute the program you have written, and then it will set the output accordingly. Okay, and it will keep repeating this cycle. So this cycle, okay, how long does it take? We call this term scan time, okay. So the scan time is the time taken by the CPU to carry out the following processes. So what processes are we talking about? Definitely, it's already been illustrated over here. Read input, program execution, and set output. So let's write this down first. Read inputs, okay, program execution, or you can write execute program, up to you, and set outputs. Okay, other than that, sometimes we do use it for communication purpose. Okay, so the PLC is capable of being wired up to external device such as a barcode scanner. Okay, so you can write that down. Data communication with external devices, okay, such as a scanner, a barcode scanner, okay. And finally, it's also being used for common processes. Okay, so what type of common processes does it do? Okay, it will do housekeeping of internal bits. Okay, some students may ask, okay, what do I mean by internal bits? Okay, later on when you are studying chapter 2 of the PLC, you will learn that PLC actually have such a thing called software relays. Okay, so the thing that we are talking about is those software internal bits and things that will be used in the execution of the program. So the PLC will also do housekeeping of those internal bits. Okay? So to summarize, in a typical scan time of the PLC, it will read the input, execute the program, set the output, do some common processes such as housekeeping of the internal bits or internal relays, okay, and data communication with external devices if we connect them to, for instance, a barcode scanner or even a vision camera. Okay, so now we will go on to the next section over here. Okay, the typical scan time for a PLC is about 1 to 20 milliseconds. Okay, this one will depend on the manufacturer. So there are many manufacturers of PLC. We have Beckhoff, we have Omron, which we are using in our lab. We have Panasonic, we have Mitsubishi, Siemens. So different manufacturers will have different specifications. So if a sensor signal turns on for 0.5 seconds, okay, can you see this? This is the sensor signal. Okay, it turns on for 0.5 seconds, which is 500 milliseconds. And the PLC scan time. Okay, so a PLC scan time typically is read input, execute program, set output, correct? So this is one scan time. Okay. So it says that the PLC scan time is 5 milliseconds. The PLC will be able to detect the sensor input for how many scans? Okay, so you know that if the PLC, the sensor signal turns on for 0.5 seconds, correct, which is 500 milliseconds, maybe I should write 500 milliseconds, okay, instead, and the PLC scan time is 5 milliseconds, so can I say that you will be able to detect 100 scans? Yes? Correct? Yeah. So you can see that if the sensor signal turns on for 500 milliseconds, over here, the PLC will have scanned 100 times of it. Okay, because the scan time is 5 milliseconds for the PLC. Okay, so now we will learn about the input module of the PLC for the next section. Let's go back to our slides again. In this slide, I'm going to explain to you about this input card module and the two different type of configuration for the input card, which is the syncing input module and the sourcing input module. So let's first take a look at the diagram on the left. Okay, this is the input card, okay, and you can see that there are 16 terminals that allow you to connect your input elements to it. So why 16? Because as you can see, the terminal starts from 0 and ends at 15. So there are a total of 16 connections for you to connect your input elements. And in this example, we have illustrated two, which is the push button and the limit switch. So now let's first explain to you why I call this the syncing input module. Can you first take a look at the diode direction over here at terminal 0? So as you can see, in order for this diode to be forward biased, current must be flowing in this direction. And in order for current to be flowing in this direction, you can see that the current must be flowing into the terminal of the PLC. Hence, current flowing in is called syncing input module. Okay, and let's continue to watch how the current is going to flow to the external power source over here, which we connected a 24 volt external power source to it. So current will flow to the negative terminal of the power supply. So as you can see, current is flowing into the terminal of the PLC input module. Hence, it is called a syncing input module. Now, let's take a look at the diagram on the right, okay, where we have configured this input module to be a sourcing input module. And again, there are 16 connections. Okay, why 16? 0 to 15, which is 16. And in this example, again, I also illustrated only the push button and the limit switch. And we shall zoom into terminal 0 to have a closer look at the diode. So you can see that in order for this diode to be forward biased, current must be flowing in this direction. Okay, so the current will be flowing out from the positive terminal of the power supply to the terminal and eventually to the push button. Okay, as you can see, current is flowing out of the PLC input module. Okay, as you can see just now over here. So when current flows out from the module, it's called a sourcing input module. Okay, and comparing to the left, when current flows into the module, it's called a sinking input module. So I hope you can understand how you can actually configure your module to be a sinking input module or a sourcing input module. Take a closer look at the power supply as well, okay, in order for the current to flow in the direction that it needs to be according to the diode direction. Okay, the polarity of the power source matters. Okay, with this, we shall go to the worksheet to have a deeper understanding on the input card module. We are now back at the worksheet and we shall now take a closer look at interfacing an input module. This is the schematic diagram of the input module card we are going to use for PLC lab. As you can see from the numbering, we can allow up to 16 connections, okay, on this card. Why 16? Because you see the numbering is from 0 to 15. In other words, you can connect 16 input devices, as many as 16, to this input module card. Some students may ask, how about these two common terminals here? Well, the common terminals are meant for connecting to the power source, which I will illustrate to you later on how to connect. So depending on the polarity of the power source you connect to this common terminal, we can actually configure the input module card to be a sourcing type or a sinking type. Sourcing type means current flowing out and sinking type means current flowing in, okay, which I've shown you earlier in the video. Later on, we will illustrate more on this, okay. So a very important input element which we normally will connect to the PLC input card is the sensors, okay. So sensors, they have two types. They have the NPN type and the PNP type. Okay, just to recall, earlier on, we have learned to draw 3-wire sensor in this way, just a box, plus, minus, and a signal. Okay, so this is how we draw a sensor. So as I have told you just now, sensor can be NPN, okay, or it can be PNP, okay. Do you realize that the symbols for both sensors is the same? Yes, it is the same, okay. What is the difference between these two sensors then? Well, let me illustrate to you. NPN sensor means current is flowing into the sensor, okay. That's why it's called sinking sensor, or we call it NPN sensor. Okay, so now I will just write the word here. Okay, so this is how I remember that NPN is a sinking sensor. You ask yourself how to spell the word sinking, and you realize there's two N inside, right? So NPN is a sinking sensor. This is how you remember. Okay, PNP is a sourcing sensor, okay, which means that current is flowing out. So I'll write here, PNP is sourcing and NPN is sinking. So this diagram over here basically illustrates what I have just drawn to you. Okay, so let's recall again. This is an NPN sensor, a plus, minus, okay, a plus, minus, and a signal, okay. So sinking, NPN sinking, so current is flowing into the sensor. This is the diagram for PNP sensor, whereby you also draw a box with a plus, minus, and a signal. So for PNP sensor, current is flowing out, okay. So to simplify things for you, I have drawn these two diagrams over here to illustrate to you what it meant by NPN and PNP sensors. Now we shall take a look at figure 1, where it shows the input module of a programmable logic controller. So this is figure 1, and you can see that this is the input module of this PLC. just now I told you that this PLC input module is capable of supporting up to 16. So over here we only draw 2, 0, 0 and 0, 1. Okay, in fact it can actually support up to 1, 5. Okay, inclusive of 0, so that's why it can support up to 16 input elements. So this is a diagram for the input module. So the question asks, state the type of sensor that can be connected to this module and draw the connection of this sensor to the module at in01, showing clearly the power supply polarity. So how are we going to approach this question? First of all, take a look at this input module, okay? And we are supposed to draw a sensor here and state what type of sensor it is and draw the polarity here at the common terminal. So how should we start? Before I start doing this problem, I want to go through with you the concept of diodes again. Okay, so you can see there's a diode here. So if you can remember, which you have learned earlier in your EL tag, okay, for this diode to be forward biased, current must flow this way, okay, so that the current can go through, okay. If the same diode current is flowing this way, it will be blocked. Okay, so this is reverse bias. You are actually blocking the current flow. So if you take a look at this diode again, we want the current to flow through, right? So the current must be flowing this way. Okay, so current can either flow clockwise or anti-clockwise. So in this case, since the current is flowing this way, it will have to flow this way. Okay, and I stands for current. Okay, so just to recall again, in your physics, okay, secondary school physics, or even in your EL tag, okay, this is the symbol for a power supply or a 24-volt power supply battery source. The longer line is the positive, the shorter line is the negative. Current always flows out from the positive terminal, okay? So let's take a look at the COM now. You can see that the current is actually flowing into the COM terminal, right? So can I say that the battery source must be connected this way? Minus, plus, okay, so that the current is flowing this way. Okay, same things goes for the sensor, okay. If you take a look at the diagram now, channel 1, okay, in 01, current is actually flowing out of the PLC terminal. So I would like to draw the sensor, which what the question requested. And I know that we always connect the signal of the sensor to the PLC module. Okay, so since current is flowing out of the PLC input terminal into the sensor, what type of sensor is this? Well, previously, I have learned that if current flow into the sensor, it is a NPN sensor, as you can see over here. Okay, so it has to be an NPN sensor because current is flowing into the sensor. So I will first label this. This is a NPN sensor because current is flowing into the sensor. It's a sinking sensor. And how do I connect my plus and minus? Okay, as you can see over here, this path here from the battery source is negative. So this entire path here is negative. So I will label here minus. Okay, minus has to be connected to minus. So how about the plus? Well, I can just draw over here. Okay, and I can draw a dotted line or even a straight path is okay to show that positive of the sensor is going to be connected to positive of the power supply. So in this case, I have already drawn out the sensor. I have also drawn out the battery polarity, and I have also indicated the current flow, okay, in this particular input module. So can you see that if the sensor is a sinking sensor, because it's an NPN, current is flowing into the sensor, the input module is a sourcing module, okay? As you can see, current is flowing out from 0, 1, channel in 0, 1, okay? So this particular input module is a sourcing input module, because, I repeat again, current is flowing out from this PLC input terminal, as you can see from this diagram here. So you always look at the object perspective. If I'm talking about the PLC itself, you look at the terminal and see whether the current is flowing out or flowing in. Since in this case it's flowing out, it's a sourcing input module. Okay, because flowing out, current flowing out is sourcing. Okay, and now if I take a look at the sensor perspective, current is flowing into the sensor, so that's why the sensor is a sinking sensor, which means that it's a NPN sensor. Correct? So I'll just make a note here so that it's clearer. And also remember all these basics that I have just drawn out, okay, which you have learned earlier in your EL Tech. So the question asked me to state the type of sensor that can be connected. I already proved to you that is a NPN sensor, and I have also drawn the connection of this sensor to channel 1 in 0, 1. And I have also indicated clearly the power supply polarity. Okay, with this, we shall go to the next example over here. Now, in this question, they asked me to connect a PNP sensor to this input module. Okay, so let's connect a PNP sensor here to this PLC input module. So let's take a look. I will first draw a box, okay, and you will always connect the signal to the input module, okay. Now let's analyze the current flow. You can see that this is the diode. To make it forward bias, current must flow this way. Okay, and you can see that for the current to flow this way, the current is actually flowing in this direction, right? Clockwise direction. So let me ask you a question. Since current is flowing out of the COM terminal, okay, what should I connect at the power supply here? Okay, let me draw the battery source again. Okay, current flows out from the positive terminal, okay, and flows into the negative terminal. Okay, that's how the power supply works. So in order for the current to be flowing out of the COM terminal into the power supply, this part here will be negative, okay, and of course this part here will be positive. So I've already connected my power supply. Next, let me draw the connections on the sensor itself. So this is a PNP sensor. PNP sensor means current sourcing, right? Well, as I can see, current is really flowing out of the sensor, so it is a sourcing sensor, which is a PNP sensor. And I will connect, you can see over here is a plus, so this path is a plus, I will connect a plus here. Okay, because a sensor always needs plus and minus, it needs power to power up the sensor, okay. And how about the negative? The negative will be connected to the negative terminal of the power supply. So I've already connected a PNP sensor to this input module. One last question about this input module. Is this a sourcing or a sinking input module? Well, remember what I said earlier? Look, since I'm asking about the PLC input module, look at the perspective of the PLC input module, okay? So this is the terminal of the PLC input module where you connected your input devices, right? So from this perspective of in 01, okay, current is actually flowing into the input module, right? As you can see, I already draw the arrow. So since current is flowing into the PLC input module, so this is a sinking module. And of course, just now earlier I said PNP sensor is a sourcing sensor, right? Sourcing type sensor. So did you manage to see the link between the sensor and the module? If you are using a sourcing sensor, your module must be sinking, okay? One must give and one will accept it, okay? This is giving out current, this is actually accepting the current. Just like previous case, if the sensor is a sinking sensor, okay, which means that current is flowing in, the module will definitely needs to be a sourcing module, because this module will need to give out the current and this sensor will receive the current. Okay, with this, you should be able to understand what is a PNP sensor, what is a NPN sensor, and whether sourcing sensor should match with a sinking module and a sinking sensor should match with a sourcing input module. Now, let's take a look at this example. Now, we take a look at the example on the left first, and we are supposed to connect a PNP sensor to this input module. So this is the input module and this is one of the terminals, terminal 01, okay? And we are supposed to connect a sensor over here to this terminal. So before we do that, let's take a look at the diodes here. You can see that this is a pair of diodes unlike the previous examples. And this pair of diodes will allow current to flow either clockwise or anti-clockwise. So which direction should the current flow? Well, it depends on the sensor you are using. So take a look at this question. They ask us to connect a PNP sensor. So let's draw the sensor first. So the sensor is just a box with the signal first. We are going to connect the signal first. And I know it's a PNP sensor. Earlier, I already taught you PNP is a sourcing sensor, which means current is flowing out of the sensor. Okay, so since PNP is a sourcing sensor, the current will flow this way, clockwise. Okay, now let's draw the polarity at the COM terminal first. And as I've illustrated to you, if the current is flowing into the power supply, it means that it's connected to the negative terminal first. And the positive terminal will be this way. So this is how you connect the battery polarity. Okay, and next, the positive terminal of the power supply will be connected to the positive terminal of the sensor. And the negative terminal of the sensor will be connected to the negative of the power supply. So you can choose to draw dotted lines or you can draw solid line, okay? Since there's nothing below this sensor. Okay, with this, what type of module is this? Is it a sourcing type or a sinking type? Well, now it has been configured to a sinking type. Okay, why? Because you can see that current is flowing into the terminal 1, right? So since current is flowing in, it is a sinking module. Okay, and as for the sensor, since the module is sinking and PNP is definitely a sourcing sensor, right? Because previously I told you sourcing sensor will match sinking module. Okay, now let's take a look at this example over on the right. connect an NPN sensor to this input module. So again, look at the diode direction. You can see this is a pair of diode. It allows current to flow either clockwise or anti-clockwise. So which direction should the current flow? Well, it depends on the sensor you connect here. So we are going to connect a NPN sensor. So NPN sensor is drawn like a PNP sensor too, except that the current direction is different. Okay, so since this is an NPN sensor, current is flowing into the sensor because remember I told you NPN, right, is a sinking sensor. How do I remember? Okay, well, you just remember how to spell sinking, right? And you can see that the word sinking has two N, NPN, okay? This is just to help you to remember that NPN is a sinking sensor, which means current is flowing into the sensor. So, with this, you can see that since the current is flowing into the sensor, the current must be flowing in this direction, which is anti-clockwise. So, let's label the current direction for clarity. Okay, so, and we learned that in order for current to be flowing out from the power supply, okay, it must be a positive terminal over here. So as you can see, a negative terminal will connect to the negative of the sensor. And the positive terminal of the sensor will be connected to the positive of the power source. So this is how I connect the NPN sensor to this input module with the correct battery polarity. And just one last thing, since the sensor is a sinking sensor, this module will definitely be a sourcing module. Because as you can see from the terminal, okay, for instance 0, 1, current is flowing out of the terminal into the sensor. So the module definitely is a sourcing module. Okay, so with this, I would like you to think deeper with our next quiz question. We are now going into the section for output card module, whereby this diagram over here shows you the overview of the output module. There are a total of 16 connections for this output module. Why 16? Because it's 0 to 15. In other words, it can support 16 final control element or the output elements such as buzzers, solenoids, and light bulbs. Okay, and the output card module has 3 different types. They have the relay output, triad output, and the transistorized output. Depending on your load requirements, okay, you will then select the respective output card accordingly to be used together with your PLC. So now, let's go back to the worksheet to understand better which type of output card to be used for your application. We are now back at the worksheet where we will take a look at interfacing an output module with more details. So the output module of a PLC is used to drive loads such as solenoids, lights, buzzers, and motor contactors. And these loads are powered by an external power source, which is not within the PLC, it's an external power source. Just like the input module, which we went through earlier, there is also an external power source, which is the 24 volts DC power supply, which is used to supply voltage to the input devices such as the sensors. Okay, so now we go back to my output module, and the choice of the output module interfacing depends on the load type, load current, and the response time. So what do we mean by that? Okay, well, in the market, they have 3 different types of PLC output module. They have the relay output module, triad output module, and the transistorized output module. Depending on your requirement, the supplier will definitely ask you to choose which type of output module do you want to purchase together with your PLC. So if your load, okay, is a DC load, okay, you can choose either relay or transistorized, because a relay output can support DC and AC, and transistorized can support DC only, while triad can support only AC. So if your load is a AC type, you can choose either relay or triad. If your load is a DC type, you can choose either relay or transistorized. Another factor that you may want to consider is also the load current. Okay, sometimes the load that you connected to the PLC requires higher current. So if you need higher current, a relay output will typically support up to 2 amperes, while transistorized will be 1 amperes, triad will also be 1 amperes. Finally, the last consideration will be the response time. Okay, for a relay output is slower, okay, because it's a mechanical relay, so it typically takes around 10 milliseconds. For triad, okay, is around 1 millisecond, while transistorized will be 0.3 milliseconds. So as you can see from this table, if I have a higher load current and my load type is a DC, I need a relay output instead of a transistorized. However, if my load is a AC and I need a fast response time, I would choose a triad over a relay because it has high response time. That means it's faster. So whether to purchase a relay output, triad output, or transistorized output, it really depends on your load type, whether it's an AC load or DC load, your load current, whether you need up to 2 amperes current or 1 amperes is good enough, and even the response time. Do you need a very fast response time output card? Okay, so all this depends on your output devices that you're going to connect to the output module of the PLC. So now let's take a closer look at each individual output module card. We will first take a look at transistorized output module. Okay, so transistorized output module, earlier I learned that it can only supply DC load. Okay, it can only support DC load. So let's take a look at this output module first. This is a sinking output module, means that current is flowing into the terminal, correct? So I'll label this I, current flowing in. Okay, and since current is flowing in, so it will be, look at this direction, is a anti-clockwise direction. That means current is flowing out of the common terminal. So how should I connect the battery source? Okay, I will connect a negative to the COM because current is flowing into the battery source now, and positive, okay, on the other side. And a typical DC load, in this case, I will use a light bulb. Okay, a light bulb is a 24 volts light bulb is a DC load, and I will connect up the power supply to the load. So this is how I connect the transistorized output module. Now let's take a look at this example over here. They said that this module is a sourcing. Sourcing means current is flowing out of the terminal. So current flowing out, okay, and since current is flowing this way now, okay, so this is clockwise, so current is flowing into the common terminal, and you can see that for that to happen, this must be the plus of the power source and this will be the negative. And okay, let me change my color of my pen. Again, DC load, 24 volt light bulb, okay, which is a DC load. Okay, of course a DC load will need a DC power source, okay, as I've drawn here. Now we shall take a look at the triad output module. Triad output module, okay, the name triad means that it supports, can you see this, AC, okay, this is just to help you to remember that Triad supports AC. Okay, AC means it's like our AC power source. Okay, 230 volts. Okay, AC means alternating current. Okay, and a light bulb can also be a AC load. Okay, I'm using a AC light bulb. Okay, so I connect this to the AC power supply. Earlier, I'm using a 24 volts DC light bulb. Okay, so do not be confused by this. Over here, I'm just using a AC light bulb, which requires a AC power source, 230 volts AC power source. Okay, so this is a triad output. You can see triad. And finally, we shall take a look at the relay output module. A relay output module can support AC and DC. So they ask us to connect DC load first. Okay, why is there a method 1 and method 2? Well, because you can see relay has no polarity at the contact area, right? So I can either draw it this way, whereby the current is flowing into the COM terminal. Okay, I'll draw the direction of the current. You can see that. And again, I draw the light bulb. 24 volt light bulb. Okay, I write 24 volt light bulb. Okay, DC power source. And I connect up the light bulb together with the power source. And next, I will draw this. Okay, method 2, whereby this time round, I make sure that the current, instead of flowing out of the COM, is flowing into the COM, is actually flowing out of the COM, and the current to the terminal is flowing into the terminal. So I know that it must be going into the negative of the power supply. So I reverse the polarity of the power supply, but the connection to the light bulb is still the same. Okay, so you can see we can connect up the relay output module for DC load in two methods. One is the power supply in this direction, and the next is the power supply in the other direction. Okay. And finally, we can also connect to an AC load. Okay, and AC load means you need an AC power source, alternating current power source. Okay, 230 volt AC. And of course, with an AC load, you cannot connect with an AC power supply, you cannot connect a DC load. You need to connect an AC load. So in this case, I connect a AC light bulb. Okay. So you can see that relay output module is actually quite universal because it can support DC load, okay, or AC load. Okay, if your load is AC, definitely you need an AC power supply. If your load is DC, like this load is 24 volts light bulb, I need a 24 volt power supply. Same goes for this. Okay, and Triad only supports AC load, so you need a AC power source. And finally, transistorized, okay, it supports only DC. That's why I connect only the DC power source to the DC load. With this, we have completed chapter 1 of the Programmable Logic Controller.